Hello everyone, nice to see you again. And this is Qing. Today is the second day's application analysis training. So today's content is about the spatial analysis. Before today's training, let's review the contents of yesterday's. Yesterday, I introduced our courses, what we are going to do with this course, and then introduced to you how to install Supermap at desktop and how to download the data from the public website, and also introduced to you how to import the data to a desktop. So I think you all have already finished the data importing. So this is what we are what we were doing yesterday. So today we are going to use this data to do some analysis works. So okay, before I demonstrate before the demonstration, I would like to introduce to you some general knowledge about the spatial analysis. So let's start. I'd like to introduce to you three aspects of spatial analysis. They are query in Supermap at desktop, and the vector analysis, and also the raster analysis. Firstly, let's take a look at the queries in Supermap. There are three types of queries in Supermap. First one is simple query, and the second one is spatial query, and the third one is circle query. Let's take a look at it one by one. What is simple query? So the simple query is to browse associated attributes table with the spatial data. So you can view the attributes tables, features, and the features in the maps at the same time. No matter you click the features in the map or click the features in the attribute table, or the map or the attribute will be associated view. And it can be located where is your selection. After we select the object, we can also check the properties of the object, such as we can check the properties of the selected features, and also check the spatial information of the selected feature, and also the nodes information of the selected feature. And the second one is about the spatial query. So here I just use some examples to show you what is spatial query. Like if you want to know which countries are located on the equator, so if you have the countries, if you have the country data, and you want to know which countries are located on the equator. So here you can use this spatial query. You can find out the relationship between the countries and the equator, such as like this intersection relationship, or cross relationship. And also the second example is about the Yellow River passes through which provinces. That's same with the first one. If you want to know the Yellow River know which provinces have the yellow rivers passes, so you can do the spatial query to check the relationship between the yellow river and the princess. And also the road, and the third example is about road. If a road needs to be widened, which houses should be removed? Or here we can also use this spatial query to check the relationship between the road and the houses, and to find out which houses should be removed. So here we need to know some various conditions in spatial query, including the cross, contain, within, overlap, disjoint, touch, identity, and intersect. So so just like these cases, to find out the world countries located at the equator, the firstly we select the we find out the equator by simple query, and then use this spatial query to get to set the relationship between the equator and the world countries. Here just like the cross line region, so we can find out the countries located at the equator. So that's it. That's spatial analysis. And the last one is the circle query. So the circle query is the query, as you understand, it is to construct circle conditions to query spatial and non-spatial data. Here we need to set a standard circle sentences, such like we select what data that from where a condition here where is to put the condition, and then finally the results meet the condition will be queried. And the next one is about the vector analysis. Here, I'd like to introduce you three vector analysis. They are buffer analysis, overlay analysis, and the proximity analysis. Those are the vector analysis we usually used. So, as you know that the buffer analysis is to sorry. So as you know, the buffer analysis can extend the point or line or the region extent, and then get extension space. So for the buffer analysis, they're usually used to the urban planning, such as if you want to extend a road and you want to know which houses affected by the road expanding. So here you can you can use buffer analysis to analyze the road and set a certain wise. So and then use the and then find out the houses intersect with the road. So here is the cases to find out the buildings which will need to be demolished due to the expansion of the road. Firstly, we create a buffer and set the buffer width, and then use the spatial query to select the houses which need to be demolished. And also we can create multiple buffer zones. Just like we can create multi-buffer zone for a railway line to analyze different levels of noise affection to the residential areas nearby. The multiple buffer function can also be used for the point data set, line data set, and region data set. And the next is about the overlay analysis. The overlay analysis is an operation of comparing variables between two data sets. And here I also list some examples. Here if you want to find out the lake distribution of a certain province, so here you can use the overlay analysis. And the second example is about with the land use data in 2 years, we can get the land use change the areas in these 2 years using semi-tracts. And the third example is about with land use data and recovering forest distribution data. We can get the new land use data after recovery using update. So like this picture shows the overlay analysis is to overlay the layer A and the layer B, and then with some conditions such as clip, union, intersection, and then finally compute results, and then you will finally get an overlay layer results. So in the Supermap at the top, we provide these 7 operators of overlay analysis. And here is a case to get the land use data of a village. So if you, so here the source data, we set it as the land use data, and the overlay data set is the village administrator data. So with the clip operator, we can finally just get the result of the village data we want. And the third vector analysis is about the proximity analysis. In our reality life, we often meet this situation, just like we want to know which is the nearest supermarket to your house or to a certain place. Also here is another example about how many food production factories within 1,000 meters of a polluted river. So with these questions are all related with the proximity analysis. And in Supermap at the top, we provided 2 types of the proximity analysis. The first one is Tyson polygon, and the second one is measure distance. As you know that the Tyson polygon let me have a look. Let's go on. If you have any questions or programs, you can type in the message box, and I will see it after our training. Let's go on. So as you know that the Tyson polygon have features like every Tyson polygon contains only one discrete point. And for any location in a Tyson polygon, the discrete point associated with that polygon is the closest one among all the discrete points. And for the measure distance, this function is used to check the proximity relationship between two groups of features. For example, you can use it to find the closest stream for a set of wildlife observations, or the closest bus stops to a set of tourist destinations. And here I put a case about the national precipitation map. This application creates Titan polygons for meteorological stations in China, and then creates a semantic map to show the ranges of average precipitation for each polygon area. So we can clearly know that which areas belongs which stations. And then let's go on the raster analysis. iDesktop also provide the multiple raster analysis methods, such like the surface analysis and the vector and raster conversion functions. And also we can build DEM, raster statistics, distance raster density analysis, and interpolation functions and other, and also the hydrology analysis. Here, let me first introduce you the raster data structure. You see that in the real world, and the points and lines and regions will be present as 0.9 region in vector data, but in the raster data, the points and the lines regions are all composed by the grids. So there are three types of raster data set. The first one is DEM model, which the pixel values represent elevation information. And the second one is the grid data, which the pixel values represent business information, such as the temperature, as the precipitation value, and others. And the third one is the image data. Remote, just like the remote sensing images, satellite image, or other pictures or photos. So here you can identify which data sets are grid data sets and which data sets are image data sets by the icons in the data before the data set. And here is an example of interpolation to raster. So we know that if you have a group of points, just like the meteorological station data, so you can use the interpolation functions to get a raster data set based on the point data set. So we can estimate the precipitation district the precipitation ranges, and using the interpolation method, and we can check the values of the whole area. And in the Supermap, we provide the operators of interpolation analysis, such like the inverse distance weighted IDW algorithm, and also the spline method, and also the kriging method. So here is an example to get a raster data based on the temperature for interpolation. After we got the raster data, we can further extract the ISO lines and also the ISO regions of the raster data. And the slope function is one of the raster analysis. Here we know that the slope reflects the oblique degree. So the value of each cell represents the degree of slope. And often the slope can be used for the water and soil loss research. And also the aspect, which is the slope direction functions, which we can pay attention to some error in specified slope direction, such as the error which face south or face north or other. And the author image shows the variation of grid values by variation of colors, such as elevation. So the result is more like a 3D. It has a 3D effect. And the hill shape determines the illumination of each cell to enhance 3D effects. With the hill shape, we can overlay the DM data and the hill shape map to get overlaid map which is similar with the author image. And also it has a 3D effect. So that's the general knowledge about the spatial analysis. And the next we are going to the demonstration part. So what we are going to do in this course. Oh, hello, can you hear me now? Oh, no worries, no worries, everyone. The final videos will be uploaded to the YouTube. So if you haven't listened clearly, you can then go to the YouTube to view this video. So can you hear me now clearly? Okay. So I think I can start. I can start now. No. The lecture is not over. We are going to the second part. So the second part it focuses on this, also focus on the spatial analysis, but it more focused on the application of the spatial analysis. So based on the basic knowledges of spatial analysis, we are going to analysis of national meteorological elements. So what This section mainly uses the spatial analysis method to realize the analysis of the national meteorological elements. Here we need to prepare three data. First one is the meteorological data, which I asked you to download from the NOAA website. And the second one is the administrative data, which this data were downloaded from the from the first website data I shared with you, and also the DEM data. So let's take a look at the workflow of today's work. Firstly, we should process the original data, and then use the data for the spatial analysis, and finally lay out the results, and finally analyze the results. So let's take a look at just like we just got meteorological data with text format. So here we need to further process the data to import it as point data and do after processing, and finally use the data to do more applications. Here, in today's training, we are going to create the Python polygon, which uses the proximity analysis that I have just introduced to you, and then we also need to create a raster data with the meteorological data using interpolation method. Yes, it's okay. Yeah, I found somebody can hear me, so I think I'd better to continue our course because there are so many contents for today. And I think I will go on now. So I just introduced the workflow of today's work, so you may first know about what we are going to do today. Firstly, we should create a Python polygon with meteorological data, and then we should create a raster dataset with the meteorological elements by interpolation function. And then we should lay out the results like this. And finally, we need to do the analysis work of this. So now let me go back to the Supermap at desktop. And here I want to just introduce you this tutorial of the this contest for the second day. You can find this tutorial in the Google Classroom, and all your work can refer to this tutorial. Here I list the detailed processing to finish today's work. Genetic processing and the processing. What we are going to do, I have listed details. So now let's go back to the desktop. So I mentioned that we should use this one meteorological data here, which we already imported in at desktop yesterday. And we also need the administrative data, just like this, the city's boundary, and also we need the DM data. So this data are all for today's course. So the first let's process the data first. First, we need to process the point data. Even we have the coordinates of the point data, we need to do the further processing for application. Just like we first need to check the properties of the data sets. Here we can see that there is no projection of the data. So here we can set the coordinate of the station data. We can set it by select the by selecting the coordinate list here, and we can also copy coordinate data sets from the existed data. Just like we set the coordinates same with the DM data. And then open the the station data. Here we can find that there are some attributes, there are some fields. Some fields value is uniqueness. So here we can just delete this uniqueness fields. Here we can select, while you open the attribute table, here you can find the attribute structure. And here we found this field name. These all attributes of all attributes of the meteorological elements. So we can ordinate them. We found here. Delete all these attributes. Delete. So that the tables is much more readable. So we just delete the units information, and then next we should further check the attributes table. Here we can find this meteorological elements, just like the PRCP, which means the precipitation and the visibility and the temperature. All these values type are defined as wide character, but actually the all data are numerical. So here we need to change the this meteorological data as numerical type. Here I just to change the check the DWP as we change this as double. Because for the interpolation, only supports the numerical type. And after you change this one, and here the user date, elevation, name, station, this can be the white character type. So here, just apply it, and yes. And here we can they'll create allocate a new data set and back up the original one, so you don't worry about if you change the data can be can be found again. So here we just open, and then here I will double. After we finish this net, and then what we are going to do is to just like I downloaded the 1 month's data for every day. So here we can see the October 1st, October 2nd to October 3rd one. 31. So here I just need to analyze 1 day's data. And we can check the. We can find out the 1 data by here we are going to use the circle query to find out 1 day's data. Here we are going to find the spatial analysis on manual circle query. And here we select the data sets, the station data, and then here we should select if you can select any fields you want, and if you don't know which fields you want to select, you can just double click at the first line. It means the result will output all these fields, and then we need to input the conditions. Here we are going to find out the user date equal. We can get the equal value. The dates, here we select October 1st, and then we save the results. At the station October 1, and query. So here we got 114 station data of October 1st. And then we can use this data. We can finally add the the 1 data to the map. Here it should be like this, and then we can create a Tyson polygon now. Here, spatial analysis, find the proximity analysis, Tyson polygon, and here the data set was to make the station October 1st, and here maybe let's and the country's boundary to the current map. Because here we need to set the region of the results. So here we set the station data, and here we need to define the final region. We can just select the region. We select the region. Here we just select the whole country's boundary, and then the boarding. And okay. So here we finished the test polygon creation, and I'm to count map. So the final results will be like this. So we can reorder the layers. And the next, let's take a look what we are going to do. Next, we are going to create a semantic map to better show the result of the Titan polygon. Here we right-click at the Titan polygon results and then create semantic map. Here we can select range maps. Okay. And here we can reset the values. We can select the expression, just like we are going to express the precipitation rolling. So here, and also you can select others. Here I am going to display the precipitation zoning. So here, the next we can change the range count 6, or we can change to 10. And also we just keep 6. And here we can change the ranges, like 0. Before we check the value, we can just check the data first, so we can know better the changes of this data. Here we can see that the values, most areas are not raining, so the values are all small. So here I think we can set small values. And then take a look. So one is okay. We just need to change the color. I think this one is okay. Here we can see most areas were not raining on October 1st. We just set an integer value, just like this. And then, so here we finish the Tyson polygon creation. So it is simple. And then we save these results. We save map, precipitation, rolling. So here we save the results, and then the next we are going to find out the distribution of the precipitation. So the next we are going to use the raster analysis, the interpolation to get the raster result of precipitation. Here we also just close this map, and then we add to a new map and the administrator to current map. First thing, we just add these two layers, and then we are going to find out the spatial analysis and interpolation. Here we can first select the operators. We are going to select the creating algorithms, and then set the data set at the station 1 October 1st, and here we set field as the PRCP, and here the next we need to set the results data's name. Station October, I think in calculation. And then here we also the data range we select object, we select the country's boundary and right click, and then the next finish it. And then here we can add to the result current map. The result will be like this. So the next we are going to just leave this result in this country's boundary. So here we are going to use the clip function. Maps, you can find maps, map clip, and select object area clip. We can select the boundary of the country and right click it and remove the data we don't want to click. Just leave the interpolation results here. Here we type and OK. Then add current map. So here, this is the result of interpolation. Actually, we finished the spatial analysis in this course, but now the result is not enough for us. We need to further lay out the results to make the results much more readable. So the next, I think we are going to render the map. Here, we first save this interpolation results. Precipitation. distribution. We first save the map, and then here we can further use the reclassify function to reclassify the results, because here we can see the results. The default render is with the range. So here are too much values, and we don't know, and some values is not mean to us. So here we going to further reclassify this result. We also use create the semantic map and create ranges map. Select ranges map and default one. So here we can do as same as same with the test and polygons semantic map. Here we can change the color to blue. It's more like raining. And then we can change the range. We input an integer numerical. So it will convenient for us to read the values. So here we can see we can clearly know which errors is not hasn't doesn't ring, and which errors are ringing. And then I think we can add the city and add the cities to this map, so we can know which cities were raining at that day. Here we add the cities boundary here, and here we just change the layer style of it. I think that's okay for this, and then we can further change the station style. Here's the one or this one. And then here here we want to know which cities have been ringed. So here we should label the city's name of these areas. So how to find out which cities are ringed? Here we can go back to the station dataset and find out we can go to find out which cities are raining, and the PRCP value are more than 50 millimeter. So here but here we can see the stations. The stations is without city's name. So here we need to associate the cities with the stations. So here we can see the spatial relationship between the stations and the cities. We can know that the stations are in the cities, so they have the relationship with contain. So here we can go into use the overlay analysis to select to analyze which cities or which stations are in which cities. So let me demonstrate to you. Here we find the overlay analysis on the spatial analysis. Here we can use the intersect function, and the source data we use the source data is the station data. Overlay data set we're going to use the administrative one data, which is the city boundary data. And here we need to set the fields. Certainly we should keep all these stations fields, and then we need to associate the city names or the city IDs to the stations. So here we just select the city names and the city ID, and then OK. Here we can. Oh, I forgot to rename it. Let me rename the data set. Station over the city. So then let me check the attributes table. Here we can see the city's ID and the city's names have been already associated with the stations. So here we can remove this one. We just add this one to this count map. Here we can check if this if the stations are in each city. We can create a semantic map, and here use the. So here we can see the stations are divided by cities. We don't need the semantic map. We can also change the layer style. This one. And then we should select, should display the city which have the PRCP value greater than 50 millimeters. So here we are going to open this data, and the PRCP value. Here we are going to use the Spatial Query to find out the precipitation value greater than maybe than 50 millimeter, and then we save the results as a new result. Maybe 50 and query. So here we add this result to current map. And here, let me change the style. This one. So here we can see there are 5 cities ranked at that day. And then we are going to further label the city names. Here we create semantic map label. Here we display the city name. and change the styles. And here in folder, yeah. I think change the color. Okay, that's much more beautiful. So here we find out the cities, and then we save the result. And the same way for the, and then further, we can further add the DM data to the results, so we can know if there is some altitude factors to affect the raining. So here we can also add the DM data to current map. And then, as I mentioned, that we can create, we can use the surface analysis to create the hillshade to make a map with 3D effect. Hillshade. Let's change the colors of this hillshade. Just click at the hillshade layer and layer properties. Here we can find the color table settings and changes this to the hillshade. And then we reorder the layers, and also we set the terrain layers transparency just like 30. So here we can see it has the 3D effect. And then we can further move down, reorder these two layers under the interpolation results. And then we also set the transparency layer properties. Transparencies. So we can know which areas are raining and the relationship between the raining and the terrain. So here we can remove the layer we don't use. Okay, and then save the map. And also we can do the same with the precipitation zoning map. Here we can also add the hillshade to the map and set. If you want to know more about the mapping knowledge, you can go to our official accounts in YouTube, and then you can find out their the mapping videos. Because this course are more focused on the analysis. So here I will not introduce the mapping knowledge more. Just to show what you are going to do. And also we set the the Tyson polygons transparency. It will be like this. And here we also end the city current map and change the layer style. Highlight the cities. And also label the ringed cities. Label map. Display the city name and change the city name style like this. And then we save the results. So here, we finished the analysis, and then we need to lay out the results. Here we then like this, and then we end title and the north arrow and legend scale to the map, and then we can export the map to a picture. Here I just show the one. Sorry, I was trying to say something. Like and the title. Distribution. So here, and then we end the lost arrow. The scale, and also the legend. Here we can edit the legend. Change columns. And then remove the layers we don't want to be want to display. And as here shade and the terrain. And this one, we just keep this. And then you can also rename this the value. here you can you can edit here, and also you can modify the layer in the map. If you modify here, you can just ungroup the, and then select this one, select this sentence, and change the text. Which here we can set the stations that precipitation value more than 30 millimeters. And we can change a name, and for this one we can just edit as stations. And then we can save the result, save the layout. Restitution only. And then we can export the result to picture. So, and we can change the format of the result, and then export the result and set the resolution. Here we suppose 150. Okay. And here we can check the results. Situation only will be like this. And for the another results, you should also lay out. And for the time limit, I will not demonstrate to you how to export, how to lay out the results. You can just based on your result. And here, the most important one is after we got the result, we need to do the further analysis. Just like here, at least some points you can refer to. For the first one, you need to describe the results of the analysis. You can analyze not only the precipitation, but also the temperature, visibility, or other elements. And the second one, you can make analysis of the relationship between the precipitation and the topography, and also the other factors which can affect the precipitation or affect the temperature. And also, in addition, you can make a group of 10 series meteorological elements changing maps to analyze the change of certain period. As you see that we can download everyday's data, so you can further do more analysis with this meteorological data. And here, as this homework, at least here, the homework for you is to complete testing polygon and interpolation results of at least one meteorological element, such as the precipitation and also temperature or others. You need to complete at least one meteorological element, and then complete the analysis of results. The formats are not limited for you. You can create a poster or PowerPoint or PDF or Word, anyway is okay. So just make the file name like this. And for today's work, I also I also give you an extension homework. And if you finish the general homework, you can further do the extension homework. And the extension homework's requirements is complete spatial analysis of more than one meteorological element and make analysis of each result. And the second requirement is to make a group of time series meteorological elements changing maps to analyze the changes of a certain period. Here I made an example. So in our training, I just showed you the 1 day's analysis of precipitation. So here you can further do the other day's precipitation, just like the October 1st, October 2nd, October 3rd, or any day you want. And just like if you have a holiday, just like you have holidays in about 2 or about 3 or 5 days, and you want to go some cities or anywhere, and you want to know the climate of this area, so you can create a series of spatial analysis results of these days, and so you can clearly know which cities are raining and which cities are not raining. And also I made a temperature time series results of 3 days. Not only you can make the daily changes, you can also make the weekly changes, or the monthly changes, or the yearly changes. You can just like you can make analysis of precipitation or temperature changes on the same day in the last 5 or 10 years, or others. So here are many choices for you to make a wonderful but different but excellent work. So that's what I hope you can do after our training. So as you know that if you have any questions, you can leave your questions in this Skype, and also the work. You can get the work from the Google Class, the tutorial of this training from this Google Classroom, and also submit your work through the Google Classroom. So I think that's all. That's pretty much for today's content. Let me see if you have any questions. No. So I think that's all for today's. If you have any questions, just leave your messages in this Skype group. And tomorrow we are going to the third day's application analysis course, and the tomorrow's topic is about the network analysis. And tomorrow's course will begin at 4 p.m. In Beijing time. So don't remember the time, the training time, and we to see you tomorrow. And thank you.